This is our STEM Acebot robot.
We built it from Acebot's kit a while back. There's a whole playlist in the description showing how we put it together and got it walking.
He will be doing a series of tasks for us, but not with us driving it, but with a Claude, who's an AI.
And here's the weird part. Claude can't actually see the robot. It just looks at photos from this webcam. And this is the screen. As you can see, his hands are there. So you can see that if he goes into there and does a photo.
So basically you operate in the robot the same way you would operate the quadrocopter, except it's AI sending text messages. Here is the workflow. User delegates the task. AI reads the camera, sends commands to the robot over HTTP, and then reads distance from the sensor. All pretty simple. Let's see how it works.
The robot's original program had a web page with buttons you could click. It's cool for humans, but it's useless for AI.
And this was a long time ago. It was on February. It's also part of one of the videos we have.
Anyway, Claude isn't going to click a button. It needs commands. So he digitally ripped out the buttons.
And then we wrote Claude a letter.
Well, not quite a letter. We wrote instructions, how to talk to robot, what to look in the camera, how big step is, about a page of text. Yeah, so this is our Claude MD, which is traditional way for Claude Code to describe how to deal with the project. So it has descriptions, how to identify a robot on the frame, how to send commands, and other things like that.
And it also has the loop.
The first time we tried it, it would keep getting confused and thought the robot was looking the wrong way. So I thought the back was the front.
Yeah, so we put an arrow on it. So we put an arrow on it. As you can see here, there's an arrow on it.
Yeah, it turns out the robot looks pretty symmetric from above, so we taught Claude a trick. Before doing anything, turn 90 degrees, take a picture, turn another 90 degrees, take another picture. Now the rotation is obvious and Claude can figure out which end is the face.
Calibration!
Yeah, calibration.
Okay.
The challenge, there's a box on the table, and the robot has to push it off.
Without falling off itself, you know.
So we start up the extension.
Yeah, so we're starting Claude Code with Chrome extension, and we started the Chrome browser so Claude can connect to it. So now we want to calibrate the robot as we described before. We hope that Claude will figure it out. It will start the server and...
It's deciphering what I just said.
Deciphering, oh yeah, discombobulating.
Are you sure we're gonna make him face backwards?
Yeah, I think we should turn it on. The robot is off. Oh yeah, it was off. Type it, try again.
What?
Try again.
Calibrate the robots. Oh, good. Auto-synthesizing.
Right, see, it sent a command to check status, robot is up. Now we want to move it to the side, just like that. Yeah. So we can see Claude has connected.
Could not start video source. Is it connected?
Alright, we had to stop OBS Studio and we will record it using standard KDE recorder.
Wait, I think we should only...
Yeah, just full screen recording. Okay, yeah, let's ask it to check the page again. Alright, now we have connection established. Both robot and the camera are up.
Does one token cost 1 cent?
No.
No, it's not like that. But
Okay.
yeah, it's not free. It costs money. That's why we want to.
How much does one token cost?
Not a lot.
For Opals they charge
0.1 cent?
$25 per million tokens, I think.
Oh.
Yeah, we would fast forward that because all this stuff is not optimized specifically for robots. It is more to work with code, but we exploiting its ability to understand pictures. Oops.
Oops. I think I'll have to pick it up. Let's put it like that.
I don't think
I think it was
registered
one
the whole
wanting to go here.
Yeah, maybe we should cover this hole.
I think the hole should stay like an obstacle.
Oh yeah. Yeah, I think we confused it a little bit when we took it out of the hole. Okay, now give it a command to push the box off the table. Yeah, go. Oh, it's measuring distance. What does it show? 3.9 centimeters. It's about right. Yeah, it's not hard, and it has instruction to.
It did say it would do it carefully in small steps.
Ah, that's the problem. It shoots through the box.
So maybe I should push it off?
No, don't touch it. Let's
put it
see if it can
closer
figure
to
it out.
Don't do that.
I think I should put it closer.
Don't do that.
Oh.
Let's see if it can figure it out that it's right at the box. So the problem is
realize it if
it's
it
so
sees
close to the edge of the box that because it's cardboard, the ultrasonic sensor pushes through the box.
3. So if it does 4 steps now, it should get it done.
Interesting. Alright, so it did backward. Looking at the picture.
And thinking, why did the box not come off?
You know, it almost pushed it. Maybe we can improve it a little bit. We could make a bumper in front of it so it never stays that close to the object. Oh, hard.
Wisdom.
Did you write 5 steps?
Mm-hmm.
Did it ask you?
Yeah, so it's not sure what's happening because it stands right at the box, and it either shoots past the box or through the box with an ultrasonic sensor. Oh yeah.
Yay!
Okay, we will consider it a limited success. So I think we need to improve the sensor reading so it's not getting confused when it's right at the box.
We made the bumper out of copper wire because we don't want to wait like 1 hour or 3 or 4 because 3D printing takes a long time and it works well. It doesn't bend when it hits the box.
So with this improvement, robot is never so close, so it shoots through the box. So it shows 3.1 centimeters when we send a request to the robot. So this is a solid improvement which will make Claude less confused. Let's see if it gets any better. Alright, moving in small steps, and now hopefully sensor doesn't let us fall. It's a bit tricky because box just stuck on the edge here. Well, not really stuck, it keeps pushing but doesn't fall.
It was meant to be in this edge, but it's now on this edge.
Yeah, it's okay.
It's moving now.
Yeah, this is really difficult, complicated real-world situation, because if it keeps pushing this way, it is likely to drop both the robot and the box.
Yeah.
Oh, look, look, look. Oh, yeah, that's success.
Move your feet or I'll think there's a...
Oh, cool, it's backing up. That prototype with Claude you've just seen is great. It has one major downside. It needs internet constantly. And also, every photo and every tool we call costs us money. So we are building our custom harness. The harness runs on our desktop computer. We use our GPU to run Qwen VL with 8 billion parameters. You can see it currently on the screen. Qwen is running on our computer and controlling the robot, doing stuff with that. Stay tuned, we will post another video showing how it works. Let's conclude what we learned.
1. Claude is really good at looking at a photo and understanding the scene. Way better than we expected.
2. The prompt mattered. Once we told Claude, don't ask me questions, just try and adjust. It suddenly got way more useful. Before that, it kept stopping to check. And remember, you don't need expensive sensors. The robot has an ultrasonic sensor that's cheap, about $2.
Basically a parking sensor, and that plus a webcam was enough for AI to navigate around. Links to everything in the description. The robot kit, the modified programs, and the instructions.
Hey, if you have anything to say, you should leave a comment. And you should also subscribe and like to this channel and to the channel Outrageous Kia Gaming that's behind us. So yeah, see you in the next video.
Bye!